This presentation will help deconstruct the Georgia Standards of Excellence for 5th grade math, numbers, and operations with fractions, Standard 7, which is as follows. Students are to apply and extend previous understandings of division to divide unit fractions by whole numbers and whole numbers by unit fractions. In 4th grade, students learn that unit fractions are fractions that describe one part of the whole, and that unit fractions always have a numerator of 1. They also learn that fractions can be counted and multiplied just like whole numbers, such that 5 groups of 1/4 would be equal to 5/4, either by repeated addition or by multiplication. In 5th grade, students are asked to extend this concept to division and use the relationship between division and multiplication to check the reasonableness of their solutions. Also, just as they did in 4th grade, the students are expected to use visual models to show their reasoning. Side note, introducing new skills with concrete models is the best way for students to gain understanding of fractional concepts. It is extremely important for children to be flexible with their modeling. Essential questions, as seen here, should be translated into I-CAN statements or even learning targets, which will help direct your student learning. Students' prior understanding of whole number arithmetic often interferes with their emerging fraction number sense. In the case of fraction division, do not be surprised that students initially believe that the value of the quotients are always less than the value of the dividend as seen here, where the quotient of 5 is smaller than the dividend of 35. Also in the equation, 1/4 divided by 2, our quotient of 1/8 is also smaller than the dividend of 1/4. But, as seen in this next equation, 2 divided by 1/3, our quotient of 6 is larger than our dividend of 2. Many teachers follow a district purchase program, which may include non-unit fraction division, such as 5 divided by 2/4. Non-unit fraction division is a 6th grade standard and is not a requirement of student understanding in 5th grade. Since fraction division is literally being introduced in grade 5, it is critical to point out that 5NF7 is about meaning and understanding, not memorizing rules and procedures. This is why invert and multiply should never be directly taught to students in grade 5. However, if students discover the rule on their own, then they are demonstrating Standards for Mathematical Practice number 7 and Standards for Mathematical Practice number 8. So before we deconstruct elements A, B, and C of the standard, it is important to unpack what the standard means where it says, apply and extend previous understandings of division. This is essentially saying that we must anchor our instruction back to early division concepts taught in 3rd grade. Most teachers do not realize that there are actually 2 different meanings of division, which can affect how students reason about division contexts. One type of division is called partitive division, and the other is known as measurement division. In both types, you start with a total amount of something that you're going to split up into equal groups. In partitive division, you know how many groups to split it into, and you need to figure out the quantity in each group. Our quotient, then, is the size of one equal share. In measurement division, you have to figure out how many groups there will be. The quotient, then, is the number of equal groups. Part A of 5NF7 is mostly about partitive division, while Part B of 5NF7 is mostly about measurement division. Side note, this is not a requirement for students to know. Rather, this information is only intended for teacher content knowledge. So now let's take a closer look at Part A of 5NF7. Here students are asked to understand how to interpret division of a unit fraction, a fraction with the numerator equal to 1, by a non-zero whole number. A good story context might be, Sam has 1/3 of a candy bar left. He has to split it into 2 equal parts in order to share with his sister. What part of the whole candy bar will Sam and his sister get? So now we have 1/3 divided by 2. In providing simple, relevant story context like this, it becomes vital for students to hone in on understanding through visualization. Our model now shows 1/3 of a whole, which we will divide or cut into 2 equal pieces. Our focus becomes one piece of that third. In order to figure out the size of this piece, we need to cut the other thirds into 2 sections as well. And by counting all the pieces of the original whole, we get 6 sections. So now as we focus back on our one part of that third, we can see that we have one of those 6 pieces, which gives us 1/6 of the whole. Remember that this is part of division because we knew the number of equal parts, 2, and we were trying to determine the size of one equal share, which is 1/6 of the whole candy bar. While students are working through this concept, the teacher should be on the look for the following. Do the students understand that they are partitioning a piece into smaller pieces, so our quotient will be a smaller fraction? Are the students modeling the problem correctly? And standards for mathematical practice number 4, as well as standards for mathematical practice number 5. In Part B of this standard, students are asked to understand how to interpret division of a non-zero whole number by a unit fraction, which you might recall is a fraction with a numerator of 1. So here we'll use the example, 2 divided by 1/3. A good story context might be, Sam has a piece of string that is 2 inches long. He cuts the string into equal sections that are each 1/3 inches long. How many pieces of string does Sam now have? Our mathematical question being asked is how many 1/3s are there in 2 wholes? Again, it is very critical for teachers to provide plenty of simple, relevant story context like this one to help students visualize and make sense of fraction division. To model this, we'll represent the dividend with 2 whole fraction tiles. Then we place a 1/3 tile at the very end to represent our divisor. So now we need to figure out how many 1/3 tiles will fit in 2 whole tiles. The quotient is 6 because it takes 6 1/3 tiles. So which type of division is this? Yes, this is measurement division because we were given the length of each shorter piece of string and we were tasked with figuring out the number of equal parts. I would like to go quickly back to this part of the model. Here we figured out the number of 1/3s in 1 whole fraction tile. A great strategy to eventually use with your students is this. Stop modeling the parts once you find out the number in 1 whole. Encourage your students to unitize the number of equal parts in 1 whole and then scale it up using mental math. Once students get 3 groups of 1/3 in 1 whole, they should be able to multiply 3 groups by 2 to find our quotient of 6. This type of practice will enable them to discover a shortcut for fraction division. Also, it will support their later understanding of the invert and multiply method in middle school. While your students are exploring this concept, you should be listening and looking for the following. Do your students understand that they are partitioning wholes and that this leads to quotients that are greater than the dividend? Can your students recognize that the quotient is equal to the amount of new pieces? Are your students modeling the problems correctly? Also, standards for mathematical practice number 4 and standards for mathematical practice number 5. The third part of this standard requires students to apply their knowledge of the first 2 sections of NF7 to solve real-world problems involving division of unit fractions by non-zero whole numbers and division of whole numbers by unit fractions. In connecting these concepts to situations that students have had prior experiences with will help solidify student learning. Students should be directed to use either bar models or other drawings to help them solve each problem. Our first example is, how much chocolate will each person get if 3 people share 1/2 pound of chocolate equally? To model this, we'll represent a 1/2 pound of chocolate by drawing a rectangle and then cutting it into 2 equal halves. We then cut each half into 3 equal pieces to show 3 people and then find out the size of 1 piece. In this case, each person will receive 1/6 of the original pound. The second example is how many 1/4 cup servings are there in 2 cups of raisins? In this model, we begin with 2 rectangles to represent the 2 cups, and then we divide each rectangle into fourths. We find our solution by counting the total number of 1/4 pieces we now have. In the following video, listen and look for how the students rely on the story context to make sense of the quotient, which reiterates the need to teach fraction division in context, not in isolation, numbers only.
You just bought 6 pints of Ben & Jerry's ice cream for a party you're having. If you serve each of your guests 1/3 of a pint of ice cream, how many guests can you serve? Show your mathematical formula.
That'd be 6 divided by 1/3.
That would be a decimal. I mean, not a decimal, fraction. So It is 6 times 3 is 18.
And then 118.
Do you have to write everything?
Yes, we do.
I'm writing
All right.
So is it 1/18 or is it 18?
118.
Well, that'd be 18.
No.
It'd be a whole number.
No,
Because how many guests can you serve? So it'd be a whole number.
So based on what the question is asking, you realize it's a whole number then?
Yeah.
The following are a few tasks, tools, and assessments that can be incorporated into your lesson plans for NF7. These 3 particular tasks were taken from illustrative mathematics. Each task includes a breakdown of the solution, what the teacher should be looking for in their students' thinking, possible misconceptions, as well as probable student solutions. The tool available for fraction division with modeling was created by Conceptual Math. In the following video, you will see how to use this tool with your students. Using the Conceptual Math tool will help you strengthen your students' visualization of partitive fraction division. To begin, have your students type the contextual problem that they might be having difficulty with in the given text box and then click the lock icon. Let's say that a student is working on 1/3 of a candy bar shared equally among 4 people. Once locked, the students can grab the dividend and grab the divisor and place them in their respective boxes. Once entered, the program automatically builds the proper model to represent the given problem. Here we can see the 1/3 piece cut into 4 equal pieces. Students then highlight what they think is the quotient by clicking and then dragging the fractional piece to the number line below in order to measure against the whole. By hovering over the second number line, the number of equal pieces will appear all the way to the right. This then becomes the new denominator, which can be entered into our quotient boxes. So 1/3 of a candy bar shared equally with 4 people means that each person will get 1/12 of the original candy bar. By clicking here, we can see if we are right or wrong. The 5 tasks that are listed here are designed with a 1 to 3 scale rubric so that they can be used as formative assessments either in a whole group or a small group setting.